author of the book. The dude who wrote the book on ZFS, and the guy who ported can we have a fucking round of applause?
Yes, it's a shame that Matt Aaron's couldn't be here today, so I can't answer your questions, but the four of us will do our best to answer your questions about ZFS. So somebody should probably start by asking the question.
What's ZFS?
Are they going to officially change the name to ZFS?
No, sadly, Matt is American. Sorry, the question is, are they going to change it to be called ZFS? And the answer is no, because Matt is American. Sadly, his education didn't include how to pronounce the letter Z.
Seeing as there are two Canadians on the team, I think it should be known as ZFS, but
Actually, in English you pronounce it ZFS.
You know, in the similar.
So I'm a novice user, and I'm just really kind of wondering about the usage scenario of desktop tools. Like, how do they compare? It's definitely structured for server usage. I get all that. But what kind of use cases would it be nice for a desktop?
the question is, why should I care about ZFS if I'm on a desktop? In short, data integrity. That's why I think you should use ZFS on the desktop. Basically, there's checksums for all the data that you write there, and then there's checksums of checksums that get written there. So that's the main thing I like it for. Also, if you're doing some work on your desktop, say you're writing some code and you're going to change something, snapshots. So you take a snapshot before you start a new piece of work, and then when you're done, you do another snapshot, and you keep saving it. And when you're done your project, you can go and delete all the old snapshots.
Yeah, so with ZFS boot environments, you basically have the same state of your system before you did the upgrade, and then after, and if it doesn't work, you just reboot and choose before, then you have your file system exactly as it existed before you started the upgrade. And I think one of the greatest examples of the power of ZFS is there's a picture of Matt Olander and one of his children, JPEG, and you flip one bit, and then the middle of the JPEG, everything after it is just funny colors. And that can happen on a hard drive, and ZFS will detect that, and if you have redundancy, repair it, and now your priceless memories are intact instead of a rainbow of gibberish.
I have another clever idea. Different parts of the files on your desktop have different compressibility, so you can set that up accordingly with the ZFS compression ratio, for example.
When I ported ZFS, actually I proposed directory structure and file system structure for ZFS for basically for any installation. And this is exactly what I proposed to have, like some file system like USR SRC to be compressed by default. The same for USR objects and etc. But of course, you also want compression for USR ports, but you don't want compression for USR ports these files because those are already compressed. Also, in my case, when I switched to ZFS for my laptop, my backup times went down from like, I don't know, a couple dozen minutes to a minute or so at the most, because of the just sending the snapshot difference on my backup server. So definitely there are a lot of arguments to run ZFS on desktop.
Oh, I need to have an opinion. I think one of the things that I use the most on ZFS is the cloning, where you clone something instantly, make some changes, do some things, do a build, and instantly roll it back. As opposed to the traditional method of trying to make changes to a log structured file system, UFS file system, where you end up having to RM things, copy trees over, things like that. I can kick off a build just by doing a clone and a build, and it's almost instantaneous. If I don't like it, I go back. That's instantaneous as well.
And of course, if you use it like virtual machines on your desktop, which you can, of course, you may also think about duplication, where you have multiple source trees. That's where, so duplication is also a nice feature. So basically the question would be why not to use ZFS on the desktop? If there are any cons against using ZFS on the desktop? I don't think so. The amount of RAM we can put in a laptop these days, I see no arguments actually against using ZFS on desktop.
So that kind of raises.
Sorry.
I didn't do that.
No, I didn't.
Well, don't do that.
I James things sometimes. It's kind of my thing.
So,
That's quite the sub.
yeah. So now that you're away, raise your hand if you're running FreeBSD on the laptop that's in front of you. And now keep your hand up if you use ZFS on the laptop. Almost everybody for that reason. Yes, there's so many reasons to use ZFS on your laptop, and it's hard to find reasons not to. And like Tom was saying, just comparing rsync to ZFS incremental replication, it's like, wow. The difference is insane.
Is it an issue whether there's ECC memory on the machine?
Yes, so the question is about if ECC memory is required. Well, while having ECC is always better, the other protection and data integrity features of ZFS leave you in a better place even without ECC than you would be using some other file system that just wouldn't even detect that bits got flipped and the file you have is duplicate.
I always used to believe that, yeah, you had to have ECC for ZFS, but I'm no longer hold that way. I think that any system is better with ECC regardless of what file system it's running.
Thankfully, you can have your Lenovo laptop with ECC now, if you really want.
So actually, ECC memory is not really related to ZFS. It's mostly, of course, if you don't have ECC and you have memory corruption for some reason, it will end up on your ZFS file system with proper checksums. So you will have corruption, but it's not really related to ZFS. ZFS can detect corruption for ECC in your disk. So even if you have every disk have ECC, but if it cannot correct the error, some error will slip out through ECC on your disk. ZFS will still detect that. And we actually saw that when I bought ZFS and we started to use ZFS on my company for our storage server right away. And the storage server was like, I know, 6.5 terabyte disks or something like this. And after using it for a few years, it actually reported one checksum error on one of the disks. This is the checksum error which went undetected without ZFS checksum. It could easily provoke some strange panic or something like this if I had no checksums in ZFS, or some strange data corruption that I will spend a week or two trying to figure out what would happen. So that's where I need to know ZFS.
Or, imagine a single bit being flipped in the database in your appliance, and suddenly Josh's user is the super administrator.
Not to mention, well, there is an interesting case, but a totally different story. There was a vulnerability in OpenSSH, and basically the change to fix the vulnerability was just to change the greater equal or something like this in one condition, which resulted in only one bit change in the binary. So this one bit flip in the binary of OpenSSH it's either secure or not. So that's an interesting example of how one bit flip can cause damage.
There is an edge case where a non-ECC ZFS system can be vulnerable. If you have one VDEV, ZFS keeps some cool metadata that's only on one block device. And if that gets corrupted, ZFS lacks some of the tools of some other file systems like UFS or XFS to repair that. But keep in mind that if you were running UFS or XFS big chunks or small chunks of your file system would be blown away anyways, and you'd have no way to verify what could be trusted or what couldn't be trusted. So while in ZFS that's, you know, kind of a game over situation, even though other file systems can recover to some degree from that condition, it's almost a game over for them as well. Because now you're left with something you can't really trust and you end up restoring for backups anyways. So for the most part, Shinley and I ran non-ECC ZFS systems for years for our personal stuff. And I remember one of our systems, I think it was Shin's, he had a memory, he had a bug with the DIM, and he would run struts every week to fix his ZFS file system. And we kept that up for years. He said, well, it's not a big enough deal to even bother fixing it. And of course, we kept backups of everything, but it worked quite well. Every week or so, we report a bunch of checksum errors, and we'd scrub it, and life would go on.
I think that's the biggest thing, is that the policy in ZFS is to either give you back the data exactly as it was given to ZFS or give you an error. It's never going to give you, some of the data that's suspect. And that makes a big difference in how you can think about storage.
Also, the big difference and the big advantage of ZFS over other file systems that do checksumming is that ZFS was designed to also handle all kinds of disk problems. So, for example, for some vendors which were doing checksumming, they would keep data with the checksum of the data, right? So the checksum would be stored on the disk next to the data. So it didn't handle any problems like, for example, phantom write, where you think you wrote the data, but it actually never ended up on the disk. Or misdirect read or writes. You think you wrote the data to this place, but actually the data went somewhere else because there was some bit flip on the way to the disk or disk controller. Or you try to read the data, and actually the data was read from a different location. So if you have the checksum with the data, it would be correct, because the checksum matched the data. But in ZFS, the checksum is stored in the parent clock pointer. So it cannot happen with ZFS. If you have misdirect writes or phantom writes or error like this, if you read the wrong data, the checksum won't match it, because the checksum is not stored with the data. So that's a very nice property of ZFS. Maybe next question. Yes.
I have a question about the using the preserve mode when sending. Whenever I send a snapshot, I'm not sure whether to use preserve or not, because I'm not sure what properties are going to get preserved exactly. I've noticed that it doesn't preserve them all. Some it preserves, some it doesn't. Is there some kind of high-level concept that I could understand to help me know why some things get preserved and other things don't, that I'm missing out on?
So the question was about preservation of ZFS properties when we do ZFS send.
Yeah.
We receive them. Well, there are some couple of flags to try to do that right. Those were grown over the years, so you can preserve the properties. Not all of them actually can be preserved when you do send, but there are some missing features that I would like to use for ZFS send as well. For example, you can replicate the entire ZFS pool using ZFS send -R, and it will preserve properties then. In this way, you replicate the entire pool. But what I would like to see is to actually be able to replicate the entire pool and exclude selected file systems. So if I have a very large file system that I don't want to replicate, for example, my temp or USR objects or something like, or USR source, stuff like that, if I don't want to replicate them, I could exclude them from the stream. Even I would like the file system themselves to be replicated and properties to be replicated, but none of the data. So I would like features like this also to be there. But of course, it's just some other development goals, I guess. But with the properties, I think it's not clear. In the initial version, there was no way, I think, to preserve properties at all, and those were grown for the development of ZFS, but it's probably not very obvious how it works.
Yeah, the other thing with the preserving properties is it depends on the source of the property. If the property is set specifically on the data set you're replicating, it usually gets copied. But if it's inherited from the parent, then on the other side, it just inherits from the new parent. And so usually I don't set that many properties on that many individual data sets, other than, you know, I have compression on for everything and a couple of maybe different record size or something. But yeah, the other interesting thing we learned yesterday from Matt's talk is that ZFS send capital R is actually almost unrelated to regular ZFS send. It's actually quite different. And one of the reasons why I'm kind of in the process of moving away from using capital R is that it doesn't work with the resume feature. And basically, you could, using a script or something, you can kind of build something that can exclude the data set if you don't use capital R. But capital R does a better job of preserving a lot of the settings, so yeah, it's one of the things that hopefully will become more clear.
ZFS send is actually a functionality of the data set, right? It's not a pool-wide functionality. What we probably would want is to be able to snapshot the entire pool and to send the snapshot of the entire pool. Because also, for example, how I use ZFS for jails is when I upgrade my host operating system, I can snapshot the root of the file system and clone it to my jails. And within the jails, the entire root is actually read-only. I only have /etc, which is read-write. And this way, I can easily upgrade by just upgrading my host system and just cloning the new root to the jails. But it doesn't back up very well because the new clones are actually different data sets, so I cannot send them easily. So that's a problem. With being able to snapshot the entire pool and set the pool, I would also be able to roll back, and the rollback for the entire pool would also mean that it will rename the file system as they were before the snapshot of the pool. Because now it's just a snapshot of the given data set. So if you move data sets around, you cannot actually, without some external metadata, you cannot get the pool to the condition it were before the snapshots.
Just yes. Yeah.
Oh, one of the interesting things about what Powell was talking about was one of the newer features of ZFS send is being able to receive to an existing clone. So that if you're upgrading the host operating system snapshot and using that in the jail, but if you had that same origin on the second server, you can actually replicate it and say, you know, I want to do an incremental send, just what I've changed about this clone, and you can find a copy of that clone on the other server at this thing. It's like receive minus O. Somewhat, but like
Update origin.
yeah. Yeah. It's minus O on ZFS.
So I have one question about ZFS send and preserving properties. If you just then keep in-memory copy of the ZFS state, so we don't have to query ZFS and SQL every time we want to program with digital data sets. So we have added kernel events passed to the user space when, for example, property changes on a data set, right? So we can see when properties are applied on data sets or snapshots, and we get events via the tracking interface back to the user space. And I've seen our weak behavior on send that if you send an incremental stream of one snapshot from one system to another and have the -p option which preserves the properties, we've seen that properties the incremental stream includes properties of all snapshots, not only that one incremental snapshot which was being sent, but all snapshots which are present on the source system. And that causes excessive CPU usage because you have to process all the events from all the snapshots, even though we are sending only one. And I was wondering if that's an expected behavior or just condition which didn't get observed before because there were no events reporting that before.
Well, to sum up the question. So what Kuba was saying was that when you send incremental snapshot with dash P, actually the ZFS send will send properties of all the snapshots in the system for the given data set and not only the snapshot you are sending, right?
Yes, exactly.
So it sounds redundant, so it might be just a bug. No idea.
Okay, well, I was wondering if there's some more logic which I don't understand behind that.
I don't know.
There's one thing, so every snapshot actually has properties, but those properties are inherited from, most of those properties are inherited from the parent data set. So this causes this slightly weird thing of, so you have, compression's turned on, you take a snapshot, and then you turn compression off and create a second snapshot. When you get the properties of the snapshot from when compression was on, it will actually say, compression goes off because it's inheriting from the parent data set. And I've wondered before if it would make sense to actually have snapshots have copies of the properties as they actually were at the time the snapshot was taken. In my case, it was more of I wanted to do that for user properties, but for some of the other properties as well. So I'm wondering if when you receive a new one, or a bunch of new ones, it's actually just it's changing the property on the parent data set, and that by the way inheritance works causes all the snapshots that exist on the receiving side to have reapplied those properties. I don't know if that's what's happening there.
Yeah, well, I also have that user properties. Actually, we have a system with lots of snapshots, and every single snapshot has one user property. I see a quite big lot of central events going on for every snapshot previously indicated, including the other one that received, right? So maybe that's something I should prove the properties.
Sorry, I can't.
Okay.
Curious of patterns, successful or failure for outside of a single node application. So as an example, like HDFS or CSS, does it even make sense, or what are the good ways to do it?
I don't have much experience with trying to extend ZFS beyond a single host at a time. I've looked at ClusterFS has a mode where you can, using NFS, create a single namespace from a bunch of independent NFS servers. And for my workload, that looked like the most interesting way to try to solve that problem. But I don't know.
Sure, I can switch out of yes man mode for this for a second. So there's been a lot of effort to utilize ZFS as the backing device for various clustered and distributed file systems. Most of them have either ended up being very slow or very difficult to add nodes to. I think LusterFS right now is the current front runner in that battle, and mostly because it has the backing of Intel and Lawrence Livermore. They're both very interested in making that work. So I think that's probably the horse that's going to win the race. And just by virtue of multiple organizations throwing numbers with 2 commas in the price tag at the problem. So Luster is still not entirely easy to add nodes to, but I think they'll probably sort that out. And they'll use ZFS as just a dump block store with Luster on top of it.
So I work for a company that makes storage devices that use cluster occasionally. We took a strong looks at ZFS as being kind of the dumb block storage that we just talked about on each node and then running cluster buckets across nodes. In our case, it sounded like the thing that was the deal breaker had to do with basically when we need to migrate a chunk of data from one node to another, we you want to migrate the whole cow chain and everything. And so you basically have to do it's called block point rewrite. And,
Yes, that's
and
what it's
that's
called.
going to be a deal breaker. And so it looks like for that product, we're going to end up doing Linux and ZFS because apparently you can do that. So,
Don't mind.
yeah.
Yeah, ZFS has no way to move data around once it's been laid down. So that is indeed a patient, and you know, the mythical block pointer rewrite is of course supposed to solve that.
Okay, so block pointer rewrite is extremely difficult, of course.
Yep.
But maybe this will be a bit long. So, but basically, I have this idea for a couple of years now, because ZFS promise is to never overwrite live data.
Right.
And it's not only like higher level design of copy on write for ZFS that you always write data in new place, but it is also applied to redundancy. So for write Z. So how write Z works, well, in regular write, like write 5, right? It's 5, right? In regular write, you have like a stripe and multiple independent data of blocks of data share the same parity row,
Right.
the same parity column. And ZFS didn't want it to do that because if you update one of those blocks, there is a window where you can crash, and actually you will update the data and you will end up with parity that doesn't match the data. So all the blocks are basically now corrupted if you lose one of those disks.
Right.
So write-Z works differently. That write-Z will allocate individual parity for each data block. So you can, even with write-Z1, you can end up having 2 or more parity blocks in one row, which will take additional space, but it will guarantee that live data is never overwritten.
Right.
So my idea was to actually try to implement something like regular write for ZFS, and just to make sure, even if we overwrite live data, we know which live data we overread. I was calling it like write Y, which will be a step back from write Z. And you could do that, and it would also provide much better performance than write Z. And so what you have to do is, before you commit transaction groups to the disk, you actually have to in front remember or figure out which rows in your write Y you are going to update and store them somewhere aside, and then synchronize the disks and then commit transaction group to the disk. And if it crashes somewhere in the middle, you have all the places to check if the parity is still intact. So you don't have to scan the entire write array. And what this gives you, because of this complex write Z layout, where you can end up with 2 parity blocks in one row, this actually prevents us from doing a lot of stuff like moving from write Z1 to write Z2, or adding additional disk or extending one write Z. With write Y, it would be possible because you have the whole predictability of the offsets within the array. So you could easily extend write Y either to adding new data disk, or adding new parity disk, or even removing the disk or something like that. That would be possible because it won't change the offset of the data in the VDEV, in the write Y VDEV. So, of course, I did some experiments many years ago implementing that, but it was very rough prototype. But that's the idea I had to somehow overcome a lack of BP.
Yeah, that's exactly the reason why, well, Delphix has made device removal for ZFS. It only works on striped computers because with RAID Z, you can't predict exactly where every block is. And it would solve that problem, so you could actually remove devices from the RAID block as well. I don't know that that solves the problem. But yes, it's another way to work around needing block memory read, and that seems to be the strategy. Block memory read is some kind of mythical uniform read. Any other questions?
Yes.
Would it be possible to share an anecdote about what the final days were like, the experience where ZFS first came up and worked on FreeBSD?
Okay, so the question was how the ZFS actually came up to work on FreeBSD, how it happened. So the story begins when I was on holiday with one of my friends who was working for a large telecom company in Poland. And he was a huge FreeBSD fan, but also Solaris fan. So he showed me the notes about ZFS. It wasn't released yet, but when I read the notes, I was like, it is great. You have those snapshots, storage pool, checksuming, compression. It's like the best file system there could be ever. So then I thought that it would be great if someone would port that to FreeBSD, of course. But I thought it will never happen because we have this curse in FreeBSD that we have UFS, but all the efforts to port different file systems to FreeBSD were never completed. So we have XFS, which was read-only. We have RiserFS, which was read-only. We have HFS port with no journaling. And all those file systems never actually caught up with FreeBSD. So when I started to do the porting work, I was never committed to actually finish the work. I just wanted to start some experiments and see how it goes. And maybe in 6 months I will have something I can show which maybe worked to some extent. But when I started the work, it was so engaging, and actually in the history of my development, let's say, or being involved in programming, that was like the best project for me, because I'm sure people outside of this community will never understand, but there was so much adrenaline when I started the work, and actually I see the progress very quickly. I was able to get it, so the first prototype, I was able to read-write prototype. I was able to mount in like 10 days. 10 days and 10 nights probably, because I maybe slept like 10 hours through those 10 days. But it was so engaging that it's really kept me working. So that was a great adventure. Of course, then it took several months to actually get into FreeBSD, but of course it was great, great time. The problem I had was that ZFS was still evolving very quickly. New features were being added, and it wasn't really a one-man project to keep up with all the work. But for a few years, probably, I was the only person to maintain ZFS, and it was too much work. So I was kind of hoping that I will, when I will leave the project, maybe other people will show up, because if I'm there, people think that ZFS has a maintainer, so there's no one needed to actually help. So I started to actually back out a little bit, and new people started to show up, and actually companies started to use ZFS in their products. So more and more people were involved in ZFS, so that was great. Then of course the Oracle acquisition happened, Sun acquisition by Oracle happened. So we were also hoping that all those Sun developers will migrate directly straight to FreeBSD, and all will be roses. But of course, with FreeBSD we have a lot of problems, which I discussed with many people, that we have those low-level technologies, but we don't know how to sell them. We don't know how to package them, so those will be useful and user-friendly to the users. We had this problem with Jails. Great low-level technology, but look what Docker did, right? You can package this to be very user-friendly, very usable. And it was similar with ZFS that I blame myself, but when I ported ZFS, there were no supported installer for many years for ZFS. So to actually use ZFS on FreeBSD, you had to install UFS on some separate partition and then try to somehow manually configure everything. And I myself always forgot to either set bootfs property or copy zpool.cache file or something like that. So it was really cumbersome. And to my defense, I take an attempt to add ZFS support to this install, but I gave up. So we miss opportunities on something like this. We have those low-level technologies, but we really need to, and I fully agree with Jordan on this one, we really need to work on UIs and be able to provide those functionalities in easier way. Sorry, it's the question.
I think we have time for one more question.
So, a bunch of us, I saw the hands around earlier, a bunch of us are running ZFS on laptops. Presumably we're doing that as a, you know, as a mirror of a single device, right? So, checksumming will give us error detection, but if you're going to do that to error correction in that configuration, or do you need an actual multi-device mirror or strike or rating?
Yeah, so there's a data set property called copies, and if you set that to higher than 1, ZFS will keep however many copies of your data you specify on disk. So even in a single disk configuration, if you set copies equals 2, it will store every data block twice, and then in those instances, if there's corruption that causes a checksum mismatch, it will try and recover it from a different copy.
Okay, so basically in that case, it would be doing, like, it would be doing mirrors on the single drive.
On a single drive. Yeah.
So it's not as terrible within the more productive it could be a nightmare on HDD, and trust me, I know.
So one idea Jeff Bonwick told me about, which was never implemented, but it could be easily, is that if you expect there is only a single bit flip, and you detected corruption like this, you could still, when you cannot read the data, you could still go through all the block, try to flip each individual bit and match it to checksum, and then do the same for the checksum. Flip each bit in the checksum itself and try if it matches the data. So that would be one way to try to recover from a single bit, which is possible.
Yeah.
It would be harder with more bits, but
What? Question for the men in the middle. First, what inspired you to write the book? And second, what inspired you to port it? Like your initial thought.
So the question is about the inspiration about the porting and
Yeah, like what motivated you to keep going?
So for me, I was, well, when I joined FreeBSD, was actually working on storage. So my first work for FreeBSD was I think Geom Gate, which I presented in 2003 during BSDCon in San Mateo. So I was working on storage, mostly on Geom modules like Gmirror, Jelly, G-Write3, etc. So I was into the storage, and I also was always interested in security. So I did a lot of work with hash functions and cryptography, basically. And I also did Geom Journal, which already worked with UFS. So I had some knowledge about low-level storage, about file systems, about security, and it somehow all came together that all those skills are required to be able to port ZFS. So it kind of fit my skill set. So I decided to give it a shot and kind of work out.
Thank you for that.
Howard. For the book, it was, the original part of it was looking at the FreeBSD handbook had a chapter on ZFS, and the very first thing the chapter talked about is the custom kernel configuration you would have to do if you wanted to use ZFS on I286. And I was like, why is that first? That belongs in like the appendix at the end. Like, we don't want to scare people away from trying ZFS by being like, oh, you have to do all this thing or it'll explode horribly. And so I kind of finished up the handbook a bit and worked on that, and it was interesting. And then I thought, you know, there's a need for something at a different approach than just what goes in the handbook, which is more of a reference manual type thing. And so I wanted to do that for a while, but I kept being lazy. There's always other things I could be doing as well. And then when Michael Lucas announced that he was going to start working on the ZFS book, I got in touch and was like, well, I wanted to do that for a while, but I purposely didn't tell you that because I didn't want you to not do one, and then he never get around to doing it, and there would never be a ZFS book. But since you're doing it now, being that I've never done a book before, I just asked him if he would like to team up, and we came to an arrangement and did. But I don't plan to work on any other books anytime soon. That was a lot of work. The only reason there was a second book is because we had stuff that wouldn't all fit in the first book.
Thanks
You know,
a lot.
The book can only be so thick before you have to get a more expensive binding.
And let me just say, like, without that book and without ZFS itself on FreeBSD, users like me who are curious and really undereducated, but you know, I want to figure shit out. I'm able to do that without fear, more now than ever because of these things. So thank you very much.
Yeah, the installer was a big thing for me because, like Powell, I would always miss one of the steps. And the fact that on the FreeBSD wiki there were like 4 different recipes for doing it, for different versions, and it was just, I was like, this got to be a better. And even now, really, the ZFS install stuff is kind of drafted on the side of the installer as a sidecar, but it definitely seems to have made it a little more approachable. And big thanks to WSD for the help with that, to make that actually happen.
Any final thoughts?
So my final thought would be to just, for everyone to actually, if you contribute to FreeBSD, is actually think how we can make all those technologies more approachable, more easy to use, and work on some UIs, because we are missing opportunities like with Jails, I think with ZFS, now we have a NetMap, so we have all the technologies, but we just need the ecosystem around them to make them easy to use, because we have all the tools, but we are missing the ways to approach users that are not really into operating systems.
Thank you guys very much.